So today, we're diving into a new framework that might just flip the script on how we build AI assistants. It's called AgentFlow. And you know, it really challenges this core idea in AI that bigger is always better. The whole concept here is that the future of AI isn't just one single giant brain, but a super coordinated team of specialists.
Okay, let's get real for a second. Have you ever tried to get an AI like ChatGPT to do something really complex? You know, like plan a super detailed trip across multiple cities, or dig into some obscure scientific topic, and you just watch it, well, fall flat? It gets stuck, it starts making weird errors, or it completely forgets what you asked for in the first place. Yeah, that happens because those kinds of tasks need planning, they need to use different tools, and they need to learn from mistakes. All things that even our most powerful AIs really struggle with.
All right, so here's how we're going to break this down. We'll start by looking at why current AIs hit this wall. Then we'll cover the two big but flawed ways people have tried to fix it. After that, we'll introduce AgentFlow's much smarter team approach and dive into its unique training method that lets it, believe it or not, outperform the biggest names out there.
So right now, large language models they're amazing in a lot of stuff, for sure. But their reasoning just kind of breaks down on what researchers call long horizon tasks. And all that means is a complex problem that needs a bunch of steps and a whole toolbox of different skills, like searching the web, then running a piece of code, then looking inside a specific document. The longer that chain of tasks gets, the more likely the AI is to just get lost. Now, to try and solve this, researchers have really gone down two main paths. And you can think of them as the overwhelmed genius versus the dysfunctional team. And as you can probably guess, both have some pretty serious issues. So on one hand, you've got the overwhelmed genius. This is a single, massive, monolithic AI that's trying to do everything: planning, thinking, using tools all by itself. But as the task gets longer or needs more tools, it just gets confused and unstable. Then you've got the dysfunctional team. This approach uses a bunch of specialized AIs, which sounds good, right? But the problem is they're all trained separately and then just kind of bolted together. They can't learn from each other in real time. So if one of them messes up early on, the entire project just falls apart. And this is exactly where this new approach comes in. AgentFlow is designed to fix this mess by creating a smarter AI team, one where the members are specialized, but they can also learn and adapt together, on the fly.
So, what exactly is AgentFlow? Well, it's a framework that coordinates a team of 4 very distinct AI modules. And the absolute key to making them work together is something the researchers call an evolving shared memory. Now, this isn't just some boring log file. Think of it like a dynamic, live project whiteboard that every single team member can see, they can update, and they can learn from as the task moves forward. It's basically the team's collective brain.
So let's meet the team. First up, you've got the planner. This is your project manager, breaking that big, scary goal down into small, manageable steps. Then, you have the executor. This is the specialist, the one who actually uses the tools by doing a web search or running some code. After that, the verifier steps in. This is your quality inspector, checking to see if the step actually worked and if the team is still on track. And this whole cycle just repeats over and over until the verifier says, "Yep, we're done." That's when the generator comes in to write up the final answer.
Okay, so the team structure is brilliant, but the real innovation, the secret sauce here, is how you actually train this team to work together.
I mean, think about it for a second. If a project with 10 steps fails, how on earth do you know which step was the problem? Was it step 2 that went wrong, or maybe step 7? This is what's known as the credit assignment problem, and it is a massive headache when you're trying to train AI systems that have to perform long chains of actions. AgentFlow solves this with a really cool method called Flow-GRPO. It's a bit of a mouthful, but the idea is simple. Instead of trying to guess which individual step was good or bad, it just looks at the final result. If the final answer is right, the entire sequence of actions that led to it gets a reward. This is in the flow training. The team is learning and adapting while it's actively working, not just by reading some old instruction manual.
And this quote just nails it. You don't try to figure out which single player scored the winning goal. You reward the entire team for the win. It's brilliant. By broadcasting that final success signal all the way back to every single decision made along the way, every module learns how to work together for that one big goal, getting the right answer. So the theory sounds fantastic, right? A specialized team that learns as a unit. But does it actually work in practice? Let's take a look at the data.
First things first, just how much of a difference does that unique training method make? Well, on the left, you've got the AgentFlow team without that special training. On the right, the same team with it. The result? A massive 17.2% jump in average accuracy. So this training method isn't just some small tweak, it is absolutely essential to the system's success.
Okay, so we know the training works. It makes the team much, much better. But the real question, the one we all want to know, is how does this system stack up against the best of the best?
And folks, this is a true David versus Goliath story. In one corner, you have AgentFlow, and it's built on a pretty small 7 billion parameter open source model. And in the other corner, you have the heavyweight champion of the world, GPT-4o, a monolithic giant with a parameter count that's estimated to be just orders of magnitude larger.
And the results are, well, they're just stunning. Across 4 really difficult categories of reasoning tasks, the tiny AgentFlow system doesn't just hang with GPT-4o, it blows it out of the water. It's over 8% better on search tasks, almost 16% better on general agent tasks, and an absolutely staggering 18% better on scientific reasoning. The smaller, smarter team beats the overwhelmed genius. It's incredible.
So, what does this all mean for the future of AI? What are the big takeaways here? Well, the implications are pretty huge.
The AgentFlow advantage is really clear, and it has some serious real-world benefits. First, it's about efficiency. This means powerful AI assistants could run on smaller, cheaper hardware, maybe even right on your phone. It's also about reliability. By cutting down on errors so dramatically, you get AI assistants that you can actually trust with complex jobs. Then there's adaptability. The system literally learns on its own to pick the best tool for the task. And maybe the best part of all is that this approach scales. If you give the team better models to work with, or just more time to think, its performance keeps getting better.
So I think the key takeaway is this. We might be seeing a big shift away from this endless race to just build one unimaginably large AI brain. This research points to a very different future, one that's more modular, way more efficient, and ultimately a whole lot more reliable.
And that really leaves us with a fascinating question to chew on. Is the future of AI really going to be one giant all-knowing mind? Or is it going to be something that looks a lot more like us, a collection of smart, specialized teams all working together in perfect harmony? AgentFlow seems to suggest the team might just win this one.